Hello everyone. Today we will be solving another problem from series and parallel AC circuits. This is the problem. Here we need to find the voltage equation across a 2 ohm resistor. The I is given. The I is equal to 4 sine omega t plus 30. This problem is taken from Introductory Circuit Analysis. After the example, we have to draw the waveforms of V and I. Before going into the solution, we need to convert the resistance into impedance for AC analysis. As you know, resistors do not introduce any phase angle in between voltage and current, so the theta r is equal to 0 degree. This is the equation for impedance of resistance. ZR is equal to R angle 0. Now look into the solution. At first we need to process the equation of small I, that is the current. So here I is equal to 4 sine omega t plus 30. So if we convert these into phasor form, it will be 4 angle 30. Now this is instantaneous equation, so we will be using the peak value. We will not calculate the RMS value because we are not told to find the power. So 4 will directly go to that, and the angle with omega t will be our angle. So as we know, V is equal to I into ZR. So I is equal to 4 angle 30 and ZR is equal to 2 angle 0. So that gives us 8 angle 30. Now bring up our calculator and calculate this. So at first we need to change the mode to complex. This is a must. Then 4 angle 30 into 2 angle 0. That gives us 4 root 3 plus 4i. That is not our answer because we want these in polar form. So we'll convert that to polar form. So 8 angle 30, that is our answer. So if we convert these polar form into instantaneous equation, our answer is 8 sine omega t plus 30. Now let's see the waveforms of V and I. The blue line is our voltage equation and the peak value is 8 volt. The black line is our current equation. The peak value is 4 ampere. Since both of them have plus 30 degree angle, so they will start 30 degree ahead of our starting point. Since this is a resistive load, so they will not have any phase difference between them. That's all for today. See you in the next video.